Welcome to the 11th chapter of geometry. We'll be learning about similar figures. We have some things to review in this lesson. We're going to talk about proportions, so we need to be reminded how to convert fractions and decimals. If you enter 1 divided by 5 into your calculator, you should get an answer of 0.2. Go ahead and try that right now. Make sure that your calculator is set on degrees, not radians, so that you can do that. Then I want you to convert 0.75 to a fraction. That should be 3/4. If you don't know how to convert to fraction on your calculator, if you have a TI, I know that in the lower left-hand corner there is an arrow that points to the left. If you have 0.75 in your calculator and you push second and then next push the arrow, it will change the decimal to a fraction, and if you push second and arrow again, it will go back to a decimal. If you don't know how to do this on your calculator, go on the internet and search your calculator model, find the manual for your calculator module, and write down the instructions for converting. This will be very important in this unit, and you will be doing it quite a bit. So, another thing that we need to remember how to do is to work with cross products. If we have a proportion, and a proportion is the comparison of fractions, what we do is we cross multiply or cross cancel. So let's just begin with multiplication, and we have 4 times x times 12 equals 12 times 1. Now, why did I use that direction? You can go in any direction as long as you're multiplying across. However, be smart, and instead of putting x times 4 and then having to convert it in your brain, set it up for 4x, which is the way you're used to solving algebra problems. So 4 times x is 4x, of course. 12 times 1 is 12. And we use the lowest common denominator, which in easy problems should be something that you have just memorized to be able to do. But that will be the highest number that will divide both of these and give you an even product or an equal product. So we know that 4 is a multiple of 12, so we'll divide by 4, and that gives us an answer of x equals 3. Now let's review the definition of a ratio. The ratio is a comparison of two numbers using division. So we have the ratio of A to B, and that's how it's read. A, the word T-O, B. And that is also the same as saying A divided by B. Or you can use the divisor line to be the word 2 also. So A to B is A divided by B. We need to find a scale factor. Now, whenever you're working with similar products, you're going to be looking at, technically, the scale factor of those products. We'll be comparing triangles for the most part, or polygons in this unit, and we'll have smaller ones compared to larger ones, larger to smaller. So in your text, they have a model of a Ferrari F430. They're telling you the actual car is 14 feet 9 inches long. They have a model that is 7.08 inches. They want to know how far that was scaled, or what this was divided by to get that scale. Everything in that model will be to scale. The steering wheel, the headlights, the doors on the car will be a certain percentage of the actual car size. So the scale factor is also known as the letter K. And we'll express this word problem like this. K equals the model length compared to the actual length of the car. The model length was 7.08 inches. The car was 14 feet 9 inches. We have to have similar units of measure. So 14 feet 9 inches is 177 inches, which is 0.04. Now when you express scale factors, you can use decimals, but if they ask you specifically to express as a fraction, you need to remember how to convert this to a fraction. Even though you might have your calculator at hand, you still need to understand that 0.04 is the same as saying 4 over 100, which is 1/25. Now, a proportion is a statement of equality between two ratios. So here's an example of the algebraic expression of a proportion. A is to B equals C is to D. We call this proportion, each piece of this proportion has its own definition. So we have the extremes, which are the first and the last number of the proportion. So the extreme would be A and D. So if you considered the way that you would write the proportion, A is 1, B is 2, C is 3, and D is 4. And the first and the fourth number, or the first and the last number, would be A and D. Now the numbers that are in between are called the means, and you probably don't remember all of this from Algebra 1, but the means are the middle numbers, and that would be B and C. If you're multiplying both sides of the proportion by the least common denominator, the fraction will be cleared. So in a process like this, where you have algebraic expressions, you need to understand what to multiply by. So here's that expression again, and we take the bottom parts of the fraction, the denominators, and we take the least common denominator because we don't know what these numbers for B and D are. We have no values yet. We multiply by both of them together. So if you multiply both sides of the proportion by the least common denominator, the fraction will be cleared. And that is our goal. So we're going to multiply both sides by B times D, because those are the values that are in our denominators. So we can cross cancel the B's on this side on the left side of the expression, and we can cross cancel the D's, and we're left with AD equals BC. And this is very important for what we'll be doing. These are basically known as cross products when you express AD equals BC. You should have in your notes that A over B equals C over D, and then have an arrow and put AD equals BC. Use that when you're working these problems. So this leads us to the cross product property, and this property is exactly what you should have in your notes. In a proportion, the product of the extremes is equal to the product of the means. Example 2, it says solve each proportion. So we have a proportion, x divided by 5 equals 9 divided by 15, or x is to 5 equals 9 is to 15. Use the cross products property. And if we multiply across, we have 15x equals 45. We look for our least common denominator, and we find that we can divide and I always try to divide by whatever is next to x and see if it'll work. So you know that x is your goal, so that is your best bet. So we're going to divide both sides by 15, and 45 divided by 15 is 3. So another part of example 2, we have 2 is to y equals 3.5 is to 14. If we multiply across, we have 3.5y. 2 times 14 is 28. Divide both sides by 3.5 and we have an even number, y equals 8. And quite a few of our problems will have mixed numbers or combinations of numbers in your numerators. We're going to still use the cross products property. So we multiply 3 times 2z, which is 6z. And I put an extra step in here. You don't have to write this step unless you have trouble with distributive property. Remember that when you use distributive property, everything inside the parentheses is multiplied by the outside number. So 4 times z plus 1 is 4z, 4 times z, plus 4 times 1 plus 4. Now we have z's on both sides of the equal signs, so we're going to combine like items by subtracting 4z from both sides, and that gives us 2z equals 4. Let's divide both sides by 2, and z equals 2. Now all of the following proportions are equivalent to a over b equals c over d, the proportion that we've been working with. This is possible because the product of the extremes and the means remained unchanged. So whatever value you put for each one of these letters has to remain the same for all of these things to be true. So let's begin by the first proportion, which is a over b equals c over d, or 3/4 equals 6/8. First of all, this proportion has to be true, and the way we know if it's true is 4 times 6 is 24, 8 times 3 is 24. Now, you can invert both of these proportions without even thinking about it and just switch tops to bottoms. So 4 over 3 now, and 8 over 6. And if you cross multiply, they're still both equal to 24. Now you can switch the means, which are the two numbers 4 and 6, and you can switch them by just putting the 4 over here on the top and the 6 on the bottom. But guess what? The proportion still remains the same. It's 24 equals 24. And now you can switch the extremes. The a and the d portion, the 3 and the 8, now become 8 and 3, and the proportions remain the same. 24 equals 24. The great thing about this is if you understand these properties and you're working on some of the problems that you're going to encounter, you can just quickly switch them without even doing the math. Okay, let's move on to a definition. We have similar polygons, and this is the root of what we're getting to. Are polygons in which corresponding angles are congruent and the corresponding side lengths are proportional. So we had to review proportions so that we understand this definition. So we have two triangles here, ABC and DEF, and whenever we compare triangles, remember they have to be in the same order. So if I go A to B, then I'm comparing this angle that has 1 hash mark to an angle with 3. And if we look at the smaller triangle, there's 1 hash mark to 3. So for those of you who struggled when we were doing congruent triangles, I want you to draw these triangles and put the markings in there so that you can actually visualize it while you're doing it. So ABC is congruent to DEF. this means also, and it can only be, is similar to DEF. This is true only if angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F. Now, we cannot say that these are congruent because you can see that the length of AB is 16 and the length of DE is 8. Even though the angles are congruent, the side lengths are not. However, if you take a quick look here, they are in proportion. 16 divided by 2 is 8, 12 divided by 2 is 6, and 8 divided by 2 is 4. Or we can say that AB is to DE as BC is to EF and CA is to FD. And these are the things that have to happen for two polygons to be similar. Let's take a look at example 3. Determine whether the triangles are similar. If they are, write a similarity statement and state a similarity ratio. If not, explain why not. So, we have two triangles. We have PQR and XYZ. Now this time they did not make them looking the same as each other. If you have a problem with that, redraw them. So, are they similar? And if they are, remember from way past, many chapters back, that we have a postulate. It's called the AA postulate, similarity postulate. So, angle, angle to angle, angle, angle. And the answer here, and we only have to prove this true for two angles. Angle Q is congruent to angle Y, and angle R is congruent to angle X. So we know that we have three sets of angles in our triangle, because if we prove two sets of angles, the third will also be congruent. And we've got two sets of angles congruent, so we can use this postulate. So, consequently, we can state that angle P and angle Z are congruent. And this is all part of proving whether they're similar. And we also have to find the ratios of the sides to see if they are congruent also. So once again, we take a side, and you can start with any side, as long as you're starting with sides that compare, where the angles compare. So they start with PR. PR has no marking here and 2 hash marks. So if you go and look at this triangle, you have no markings and 2 hash marks. So PR is congruent to ZX. PR, or let's say it's in proportion to ZX. Sorry. That would mean it would be 27 to 36. So 27 in ratio to 36 equals 3/4. We found the lowest common denominator to multiply by, and that was the number 9, and that gives us 3/4. Now, if this set of triangles here is going to be similar, the other sides will also have to equal 3/4. So they compared PQ, which is no marking to 1 marking, which would be ZY, no marking to 1 marking. PQ is 24, ZY is 32, and 24 32nds is 3/4. And QR, 1 marking to 2, would be YX, 1 marking to 2, and that's 33 over 44, which equals 3/4. So, triangle PQR is similar to ZYX. The constant, or the similarity ratio is another way that you can express that, is 3/4. This is what's the same for all of them. Okay? And so this is similar, and we stated the ratio, which is 4/3. Let's skip to example 5 and take a look at some a different kind of figure instead of a triangle. And we have 4 sides here. So with 4 sides, what we'll do is find each measure in similar trapezoids, JKLM and TUVY. So for this example, they've told us they're similar already. So we don't have to prove similarity, but we're going to use ratios to prove that things are similar. So the measure of angle T in the smaller trapezoid will be equal to the measure of angle J. We can state this because they're similar. So go ahead and mark that on your notes, and you should have drawn trapezoids. Whenever I do an example for you, you should be putting those in your notes. Draw the trapezoids and add the 110 degrees. Now, the measure of angle W, this angle up in the upper right hand corner, equals 180 minus the measure of angle T. Remember that the two angles on a side of a trapezoid or a polygon will be equal to 180 degrees. So this is the way that we can solve for additional angles. So 180 minus measure of angle T is 180 minus 110, which is 70. So now the measure of angle W will be 70 degrees. I went ahead and zoomed this in so you can see it a little better, and so I can write on it. And I also just jumped ahead and filled in the measure of angle M here, because if J and T are 110, both of those angles are going to be 70 degrees. All right, so now we can compare some sides, and JM, this side right here, compares to TW. Now I can't put a congruent sign there, but it is in ratio to TW. And KL, this side right here, sorry, wrong side. KL, let me get rid of this. Compares to UV. So JM, we don't know what the length of JM is, but we do know the length of TW. TW is 12. So we can add that to our proportion, and we can now compare the side KL to the side UV. Now, one of the things you have to be careful of is when you're setting up proportions, if you're going from larger figure to smaller figure, for every proportion you have to set it up the same way. So this will be 15 over 10. 15 over 10, large to small. And now we can use our cross products and multiply across, and JM is 10 equals 12 times 15. and I don't really care for how your text did this, but if JM is 10, 12 times 15 is 180. We would then divide both sides by 10, and JM would equal 18 centimeters. So JM would be 18. And we can now do the same thing with VW to LM. So VW, and now they're picking smaller to larger. They're doing this to make you think. So be sure to set up your portions that way. VW, we don't know what VW is, but LM is 20. So we can substitute that in our proportion. And they'll use a side that we already know the value of. So they're going to use UV to KL. UV to KL, which would be 10 over 15. And if we go ahead and multiply across, we have 15 VW equals 20 times 10, which is 200. If we divide both sides by 15, we end up with 13 1/3, or it'll be 13.3 centimeters. So, just a couple of clues about these. When you have, and let me go ahead and erase all my markings. When you have information on the figures you're using, one of the first things you want to find is the ratio that you will be using that will help you out when you're solving. So as an example, if I look at every one of these sides, the only set of sides that has figures for both sides that are similar are these two. So consequently, we end up using this ratio twice. The 15 over 10, and then in the third step, 10 over 15. That ratio will be help you to set up the ratios for all of the other sides. So you can solve for the TW to JM by using that ratio because you have one side length, and you can solve for the LM to VW because you have that other side length. So that's one of the first things you want to do, is look for a ratio that you can use to help you solve all of the sides. In Chapter 11, I've divided all of your homework assignments into two. This means that I expect you to get 100% on each one of these lessons. Be sure to use the answers in the back of your book so that you can back solve to make sure you have those problems correctly. Now those are only the odd answers. So if you want the answers to the even answers, contact me and I will send you those answers so that you can double check your work. So for lesson 11.1, and I'm going to put A on here. I should have done it on the main lesson. We will be doing numbers 1 through 8. And for number 1, go back and see example 1 in your book or watch it again on the video and solve the problem that way. In number 2, 2A and B, you're comparing to a class of 30 students. So when you read these problems, the first value you're given isn't always the value that'll be in the numerator. You have to think about what you're comparing to. So this is a class of 30 students, so that will be in the denominator for the first two, for 2A and 2B. So the number of students is in the denominator, okay? The other numbers will go in the numerator, but 2C is different. They're comparing band members to non-band members. So band members will come first, and then non-band members. So that would be written like this: band members to non-band members. Okay? So if you don't know how to set that proportion up, that fraction up, go ahead and look at the beginning of this lesson and see how they're setting up the ratios. This is very important because as you go along, if you don't set up a ratio in the right order, then you'll get the problem incorrect. Okay? Shouldn't have any difficulty with the rest of the problems. They're all doing cross multiplication. So once again, if you have any questions, be sure to contact me. If you need the answers to the even answers, that's fine, but be aware, if you just answer with that number, I will not consider it correct. I need to see your work. Have a great day, and we'll be back for 11.1a.